Hello friends, we were discussing about the advantage of the negative feedback circuit, and in our previous video we have seen how to reduce nonlinear distortion by negative feedback. Now in this video we are going to discuss about the mathematical expression for the decrease in nonlinear distortion in a amplifier. Okay, see, this is the one transfer function graph of one nonlinear amplifier output versus input graph. Here for input voltage 0 to 1 volt the gain is 10, and for input voltage of 0 to minus 2 volt the gain is 5, and with further increase of input voltage beyond 1 volt the gain there is no longer amplification of the output voltage is there, so it is parallel line with the input voltage. And when input voltage increases from minus 2 volt in the negative direction, then also the amplifier goes in negative saturation region, so that there is no longer gain or amplification of the output voltage is there. So output voltage becomes a parallel line of horizontal line parallel to the x-axis, that is input voltage. Clear? So this is one nonlinear amplifier. We are giving the input voltage xi and we are getting output voltage x out across a load resistor RL. Clear? Now see, we know for a general amplifier V output equal to G into V in. Okay, but this is applicable only when the gain is constant. That means for linear amplifier this relationship is valid, but for non-linear amplifier the relationship does not valid. In case of non-linear amplification, the expression for the output voltage is V output equal to V offset. I will explain what is V offset, plus G into Vi plus K1 into Vi square plus K2 into Vi cube dot. Okay, these expressions K1 into Vi square plus K2 into Vi cube and higher order polynomial terms all are basically non-linear terms. Okay, and G into Vi is the linear term, or for ideal amplifier it is the relationship between output and input, that is V output equal to G into V input. And what is V offset? This is one term, one voltage which is independent of input voltage. It is one constant for a particular temperature, but as temperature varies this voltage may vary. This is offset voltage for amplifier. Okay, like for every electrical instrument there are some offset voltage. This can act like a noise. For different temperature the value may be different, so this is the offset voltage. So the general expression for the output voltage for a non-linear amplifier is this one, that is V output equal to V offset plus G into Vi plus K1 into Vi square plus K2 into Vi cube plus dot. Clear? Now this is the case when we are applying negative feedback via H block. Okay, see here minus sign is there, so that means we are subtracting the feedback signal H into X output with the X input, and we are getting this error signal E, which is equal to Xi minus Hx output. Clear? So this is the simple negative feedback scheme that I have already explained in my previous video. And now for the G block, what is G? G is the gain block whose gain is G, that is open loop gain of the amplifier is G. Okay, now suppose this is a non-linear block, that means it is not an ideal amplifier, it is a non-linear amplifier block. Then obviously what we can write in case of these VIs, we can substitute the VI by the E, because now in the non-linear amplifier E is the input. Clear? So what we can do, we can, this is the expression for open loop gain. That means when feedback is not applied, then Xi, which is equal to Vi. Here Xi I have taken as general case. Now for particular case let us take as voltage, input as voltage, then it will be Vi. So V output equal to V offset plus G into Vi plus K1 into Vi square plus K2 into Vi cube plus dot is the expression for open loop amplifier. But when we apply the amplifier with feedback, then the input of the non-linear amplifier is that is the gain block is basically E. So we can substitute the Vi by E, and we get V output equal to V offset plus G into E plus K1 into E square plus K2 into E cube plus dot dot. Clear? Now in the next step, what we can do, instead of E, we can substitute this expression, that is xi minus hx naught. So basically here what we can substitute, Vi minus h into V naught, that is V output. Okay, so instead of E, we can substitute Vi minus h output in this expression, and we get this one. This thing we already got, that V output equal to V offset plus G into E plus K1 into A square plus K2 into E cube plus dot dot. Now instead of E, we can substitute Vi minus h into V output, and we get V output equal to V offset plus G into Vi minus h into V output plus K1 into E square plus K2 into E cube plus dot dot. Just in the second term, that means just in the linear term, we have substituted the E by Vi minus h into V output, the general expression of the error signal. Okay, now what we can do, just split this, you will get G into Vi minus G h V output. The term, take the term G into H into V output in the left hand side, and you will get V output plus GH into V output is equal to V offset plus G into Vi, from here G into Vi, okay, plus K1 into E square plus K2 into E cube plus this, all the nonlinear term will come here. Clear? Now take V output common in the left hand side, and we will get V output into 1 plus GH equal to V offset plus G into Vi plus these nonlinear factors, that are K1 into E square plus K2 into E cube plus dot dot. Clear? Now we can take 1 plus GH in this right hand side, and what we get? We get this expression we already got in our previous slide, that V output into 1 plus GH is equal to V offset into V offset plus G into Vi plus K1 into E square plus K2 into E cube plus dot dot. Now we take 1 plus GH in the right hand side, and we get V output equal to V offset by 1 plus GH plus G into Vi. Okay, here I forgot to write G into Vi into 1 plus GH. Okay, 1 plus GH plus K1 into E square plus K2 into E cube plus dot dot by 1 plus GH. This is the whole nonlinear term. Okay, clear? Now what we can get, instead of the, we substitute the K1 into E square plus K2 into E cube plus dot dot, this whole nonlinear term by N. Okay, this is the nonlinearity, this is showing the nonlinearity. Okay, so basically this is denoted by N. So what we get, V output equal to V offset by 1 plus GH plus G into Vi by 1 plus G into H plus N by 1 plus GH. Okay, this is the expression for output voltage for a nonlinear amplifier. Now see carefully what is happening. The offset voltage, due to application of the negative feedback scheme, the offset voltage is reduced by a factor 1 plus GH. And this thing you all know, that V output is equal to G by 1 plus GH into Vi. This is nothing but the relationship between output and input voltage for an ideal amplifier with feedback. And see the nonlinearity term. When feedback was not applied, then the nonlinearity factor was this one, K1 into E square plus K2 into E cube plus dot dot. But now the nonlinearity factor is N by 1 plus GH. That means nonlinearity is divided by 1 plus GH when we apply negative feedback scheme. That means due to negative feedback scheme, nonlinearity reduces by a factor 1 plus GH. This is very important concept in application in mathematics, that numericals may come, that you remember this thing only, that due to application of negative feedback, the nonlinearity of an amplifier is reduced by 1 plus GH. This is what the derivation I have discussed. Okay, this is all for this video. In my next video I will show you some more concepts. Thank you for watching.